Hello, in this section 5.4, we're going to talk about how we can tweak our model with the same span data. So in our last section, we have used count vectorizer, which is bag of word, you're doing the word frequency count. However, TF-IDF is slightly different, as we have mentioned before. That is, it uses inverse document frequency as opposed to just the word frequency. So let's take a look at the effect of using TF-IDF vectorizer versus other versus count vectorizer. So the same thing, we're gonna actually initialize it, right? So we're gonna actually start with TF-IDF. This is coming from a scalar, and then we're gonna assign it as this variable TF-IDF, and then let's look at our DF. We're gonna have span, message, and message cleaned, and this is just a numerical span, but don't have to worry about it for now. Let's say we use we have TF-IDF, and then we want to pass this entire column, the message claimed, into TF-IDF.fit transform, right? And then X is going to be our feature matrix, just like before, and then Y is our span, right? This column, which is our target variable. So now we're going to do the train test, let 80-20, right? So now let's try fitting into random forest, right? You can actually see the accuracy is like 97%. It's not bad. However, if you look at the confusion matrix, right? So which you'll pass the actual Y, right? And then this is what you have predicted. So you can actually see what you the diagonal ones are the correct classification. And then this is type 1, this is type 2. So compared to what we had before, type 2 error is slightly higher. So what we had before was the combination of count vectorizer plus logistic regression. So it's actually not doing better than what we had, right? So let's try something else. So instead of using, say, random forest, what if we try gradient descent, right? Gradient descent boosting. So you can see the accuracy score is almost the same, right? 97. And then what about the confusion matrix? So you can actually see it's slightly better than random forest, but it's not as good as what we had before, like this, right? So this is what we had before for logistic regression with the count vectorizer. So it's not better. So yeah. So currently the best one is still count vectorizer plus logistic regression. And now let's try something like, this is a quick trick they can do to include bigrams as well as trigrams, right, to your words. Not just one word per token, or you can actually grab 2 words and then consider that as 1 unit, right, or 3 words, so that we call them bigrams or trigrams. So you can actually do it this way, and then do the same thing for fit transform, and then do the split, right? And then you can see that indeed, if you use like gradient descent boosting, the accuracy score actually went down, and then the confusion matrix is telling us that type 2 error actually is worse now, right? So looks like so far is still, the best one is still count vectorizer, is right. So it's still count vectorizer with logistic regression. So what if we do something like TF-IDF is equal to TF, right? So what if we just use TF-IDF with logistic regression? I don't think we have tried that one yet, right? So then we can pretty much let's just use what we had before. I don't think we have tried this one yet. So TF-IDF dot fit. We are going to do fit transform of DF dot message, and then clean, right? So cleaned, and so this will become our X, and then our Y is the same one. It's going to be span, and then we can actually do train test split, and then passing X, Y, and then maybe we can just copy over from here. Okay, and then. Okay, so this is what we have. No, let's start from here, and then we are going to have something. Yeah, the score is actually worse. So, and then needless to say, I think the confusion matrix, if you look at it, it's gonna be, it's not gonna be better than what we had before. So the conclusion is that count vectorizer plus logistic regression, our initial trial actually is leading us, giving us the best results. So these are the things that you can try, right, when you actually try to refine your model and try different, tweak your model or try different parameters that you want to pass into your model to see if you can improve it, right? So it sounds like in this case we weren't able to improve it, but as you can see, that modeling takes a lot of iterations. right? So this is it. Thank you.